All right, 9.3 is where all this stuff starts getting fun. We're still going to be graphing rational functions. However, they're going to get a little stickier. Now, f of x is p of x divided by q of x, just like we talked about before. But let's say that p of x is a sub m times x to the m plus blah, 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 more stuff, over b to the n times x to the n plus blah, 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 more stuff. Here's what's important. Now, here's the thing. A sub m is just like the coefficient in front of x. All right? There's nothing fancy. It's just a coefficient. The same thing with b of n or b sub n. They're just coefficients. What's important here are these exponents. X to the m power and x to the n power. All right? Now, here's the thing. Our vertical asymptotes are still going to occur where they always occurred. What makes the denominator 0? What makes the denominator 0? And the way we're going to find that out is we're going to factor and ZPP. All right, what makes the denominator 0? That's going to be our horizontal asymptote. Where it gets tricky is the horizontal asymptote. We've seen it where there's three ways that this can come out. Let's talk about this. If the top exponent is greater than the bottom exponent, then there's going to be no horizontal asymptote. All right, that one's new. We've never seen that. We'll do some examples of that in just a minute. The other scenario is where m is equal to n. We've seen this. This is going to be, if m is equal to n, then y is equal to a divided by b. Or in other words, a is or y is equal to the ratio of coefficients. We've seen this the past couple of days. We've seen examples of those. It's the ratio of leading coefficient. Now, the other scenario is m is less than n. Now, here's the thing. The book says it's y is equal to 0, but I think that's wrong. I don't think that's right. Y, in my opinion, is y is equal to k. Now, let me show you why. We've done examples where it was y is equal to 3 divided by x minus 4 plus 2. M, the top exponent, is less than the bottom one. Look at this. This is x to the first downstairs. Since there's no x up here, that's the same thing as like x to the 0 power. And when we did this, we had the horizontal asymptote was y is equal to 2. Now, up here, when there's nothing here, right, that's like saying there's plus 0. So that's why the book says it's plus 0. But here's the thing. I don't want us to forget about the couple things that we did the past few days, all right? So here's the thing. Is y is equal to k. Let's do some examples of this stuff. So let's look at this first one. 2x squared divided by x squared minus 1. Guys, just like everything that this chapter, the first thing you need to do is factor. This is going to be x plus 1 and x minus 1. Now, here's the thing. What makes the denominator 0? In this case, there's two numbers that make this denominator 0. Negative 1 and 1. So, this is going to be x is equal to 1 and x is equal to negative 1. Those are our two vertical asymptotes. Two vertical asymptotes like that. Now, our horizontal. Which scenario does our horizontal fit here? Now, going back to before it was factored, I got x squared on top, I got x squared downstairs. Which one of these three scenarios does that fit? That fits m is equal to n, yeah? So that means that y is equal to the ratio of coefficients. No, coefficient up top is 2, the coefficient downstairs is 1. So here, the horizontal asymptote is going to occur at y is equal to 2. So there's a horizontal asymptote at y is equal to 2 like that. All right, so look at this weird graph, right? Now, oh yeah, notice that I didn't give you a grid, right? I just gave you coordinate plane, so it ain't got to be nothing fancy. We're just going to make a sketch. So let's pull out our calculator. Let's see what this looks like. Y equals, we're going to do 2x squared divided by, make sure you put the denominator in parentheses because it's subtraction down there. And I'm going to zoom 6 it. Whoa, look at that thing. I'm going to keep this on top. So this graph is going to look like, well, it looks like it kind of, the asymptote kind of, or the graph kind of skates along these asymptotes on either side here. But look at this. This looks like a kind of, it looks like a parabola that's in the middle like this. It doesn't look like it goes past the height of the x-axis. Huh. All right, so here's where it gets fun. The domain and range get weird. First of all, let's talk about the domain, the x values. What x values are being used? Well, this arrow indicates that everything this way is being used, right? So all this gets used until, what's an x value that's not being used? -1's not being used, right? There's an asymptote there. But then 0's got a point, right, on this parabola thing. In fact, everything between -1 and 1's getting used, but 1 is not getting used because there's another asymptote. Then on this purple line, everything past 1 is being used. So here's the thing. The domain is x is all real numbers except what's not being used. 1's not being used and -1's not being used. There's two numbers that aren't being used for the domain here. Now, let's talk about the range. The range gets a little sticky. Check this out. Everything up here gets used. Everything down here gets used. But let's look at coming from the south. These arrows go down forever and ever, right? So as we come up, it goes up. It seems to stop around 0. Right? That's what our graph looked like. And then there's like this empty space, and then there's this asymptote again, but everything going north of the asymptote is being used. So here's the thing. We need to figure out just how high up this parabola goes. How can we find out the maximum point of that parabola? That's right. We're going to go to our second trace function, and we're going to go to maximum 4. Now, left bound, make sure your spider guy is to the left of the vertex. Right bound, make sure he's to the right of it. Whoa, I'm way to the right of it. Right? Press enter. Put it right on top of there. Ooh, look at that. Mine's weird. But here's the thing. I got that E in there. What does that E mean? E means 0, because that's times 10 to the -6. So that's -0.0000001257. Same thing here. So this is 0, 0. This point is just as we suspected, 0, 0. But look at this. There's a dead space between 0 and 2. Right? There's this dead space where no y value has got a point on the graph. So that means that our range, we have to say that somehow it's this area and it's this area. Well, let's talk about the bottom part. That means that y is less than or equal to 0, because it does include 0, right? Less than or equal to 0. And now our range is this is the dead space, but at 2, everything higher than 2 has got a graph. So it's going to be y is greater than 2. So the range is a little bit tricky now. We got to look at graphs and analyze them and see what's up. Let's go on to number 2. Right, so our vertical asymptote, what makes the denominator 0? In this case, x is equal to 2. So I'm going to sketch that. X is equal to 2. Oh, that's negative 2, my bad. X is equal to 2. Then our horizontal. Now, which scenario is this? Remember, there's three scenarios. When the top is bigger, when they're equal, and when the bottom exponent is bigger. In this case, the top exponent is 2, the bottom exponent is 1. So what scenario is that? M is on top, so M is greater than 1. This is the first scenario. So that means that there is no horizontal asymptote. There's none. How about that, huh? Let's take a look at this. If we were to graph this, here we have parentheses. Make sure you put parentheses around the whole top, divided by first graph. Whoa, look at that thing. Alright, so kind of make a graph that looks kind of like that. Look how this kind of crosses at -1 and it looks like it goes up around 1. So like I said, it ain't going to be perfect, but it should kind of look something like what you got. So it looks like it goes like that. And this kind of goes like that. So there's our graph. Now, domain. What x values are being used? Well, everything negative up until we get to 2, right? And then once we get past 2, everything else is being used. So the domain is all real numbers except 2. Right? What about the range? Is there anything, any y value that's not getting used by this graph someplace? This goes up forever. This one goes down forever. There's no weird place. So the range is flat out all real numbers. That's it. Everything for y gets used. All right, that brings us to the last example. What makes the denominator 0? X squared plus 3. When in doubt, let's set it equal to 0. X squared plus 3 is equal to 0. X squared is equal to -3. If I take the square root, I'm going to get an imaginary number. But we're not dealing with imaginaries right now, so is there a vertical asymptote? No, because nothing squared plus 3 is ever going to be 0. So there's no vertical asymptote. The horizontal. Now, horizontal, remember, we've got to look at the 3 scenarios. Which scenario does this fit? This is where the bottom exponent is larger than the top. That's the third scenario. So it's y is equal to k. Now remember, k is what's being added after the fraction. So here, there's nothing here. That's like plus 0, right? So our horizontal asymptote is at y is equal to 0. Let's graph that guy. I wonder what this graph is going to look like. Let's graph this. So 5 divided by parentheses look at that. All right, now I know that sometimes the non-HD this is tough to see, but here's the thing: this doesn't stop. This graph skates along this x-axis, then kind of bumps up like that, and looks like that. So the domain, what x value is not being used? As it turns out, none of them, right? Everything gets used, so the domain is all real numbers. But the range, are any negatives getting used? No, no negatives are being used. And it looks like it kind of maxes out here. So how are we going to figure out where that max out point is? That's right, our max function again. So left bound, right bound, good guess. So I got that E in there again, right? It's a 0, and then 1.66667, that's 1 2/3, right? So here's the thing. You could put 1.67, but we know that's 1 2/3, which is the same thing as, this is 0.05 Again, if you put 1.67, I'm not going to take off, but 5/3. So what's our range? Well, nothing below negative, right, or below 0, and it doesn't get higher than 5/3. So y is everything between 0 and 5/3. How would we write that? Think about, remember 0 and 5/3. How would we write it? It's everything between here and here. This is an and statement. So 0, if you read this backwards, this says x is greater than 0 and x is less than or equal to, because it can be, 5/3. Alright, so here's a couple of things, guys. When you're doing these types of problems, there's no telling what the graph is going to look like. Look how wonky this is. And that one. And holy cow on that one. Right? There's no telling. You have to use your calculator to see what this is going to look like. The other thing is this. And this will come up in your homework, and we'll see a couple of these as we keep going. These rules here, these rules for the horizontal asymptote only describe the end behavior. And we'll talk more about that. For right now, remember, verticals is what makes the denominator 0. Horizontal asymptote, there are 3 scenarios that we got to pay attention to. Smith out!